This here is my minimalistic home-built Z80 single board computer. It's powered by a Z80 processor clocked at 4 MHz and a 128 KB static RAM chip buffered by a lithium cell. Therefore, it can store data retentively and serves as a kind of ROM. So I have to solder one chip less. Then there is a dual asynchronous receiver transmitter, DART for short. With this it is possible to control the computer with a terminal program like PuTTY for example. The DART has a second interface which is used here to exchange files with the PC and even load programs and the CP/M operating system. Then we have an IDE port where you can plug IDE drives and with a suitable adapter also compact flash cards. The whole thing is programmed through an Arduino Mega which is plugged on a pin header. Check out the other videos in this series for more details. After the intro, I will show you how I connected a keyboard and an old CRT TV as a monitor. So stay tuned. Okay, let's go for the keyboard now. Early computers had matrix keyboards. These were connected to I/O drivers like these two MOS 6522 on a VIC-20. One of these acts as output device, where one pin after the other generates a short pulse, while the second chip is configured as input device. When you press a key, one of the inputs gets connected to an output each time, and so the operating system recognizes which key is being pressed. One solution would have been to get a used matrix keyboard on eBay and connect it with 16 wires to a parallel I/O chip or PIO. Like the Z80 and the DART, this is still made by Zilog and it is easy to get, but I found a more elegant way. Maybe you know the video where I show how to connect a PS2 compatible keyboard to an Arduino? There I explained that these keyboards transmit so-called scan codes over a serial protocol. All we have to do is to extract the scan codes from this bit stream and convert them to letters and digits, using a lookup table. In the video where an Arduino emulates a Commodore 64, I already apply this method. First I came up with the idea to decode the serial signal of the keyboard with a serial device like the DART. I'd only need to wire up the clock and receive pin, but this did not work for whatever reason. But Dr. Volt would not be Dr. Volt if he gave up here. Now let's try the way that already works perfectly with the Arduino. The DART has pins for the modem control signals like RTS, CTS and CTR. These can be used as digital I/Os. So I join data and clock to the CTRA and B pins, which are digital inputs, and translated what I already programmed for the Arduino to Z80 assembly language. With a few lines of code this was done quickly, and it works great. Awesome, isn't it? To be able to use this computer without the terminal emulation on a PC, we need an idea on how to connect a monitor or TV. I've been thinking for a long time about the best way to do so. For example, I could have an Arduino or other microcontroller generate a TV signal, like I did back in the Commodore 64 emulation video. But for me this feels like cheating if I use a processor that is way more powerful than the Z80 just for generating a video signal. But write in the comments how you think about it. Then I thought about realizing the video output only with 74 series logic ICs. Ben Eder once made a great video about this. But the complexity and the fact that I don't like soldering very much put me off. And the computer should be as simple as possible. So I finally decided to use the legendary TMS 9918 video display processor from Texas Instruments. Because this was built into many game consoles and home computers in the 80s, I could get one quite cheap on eBay. And I already have some experience with these chips because I built a graphics card for Arduino with them earlier. The PCB for this was supplied by PCB-GoGo. PCB-GoGo offers numerous services all around printed circuit boards. In addition to standard FR4 boards, custom-made boards are also available, for example from Aluminium or Rogers. And all this within 24 hours. If you don't want to swing the soldering iron yourself, they can also assemble all sorts of PCBs for you. Highest quality is ensured by the most modern testing methods. I first had a small error in my Gerber files, but thanks to their competent worldwide support the problem was quickly solved. And so PCB GoGo has more than 100,000 satisfied customers all over the world. Become a customer now and enjoy $30 discount on the cost of components of your first PCB assembly order. Order your PCB right now. The link is in the video description. So, and here is the good piece. I actually designed it for the Arduino, so we need to adapt it to the Z80 somehow. Here the manual of the Z80 helps out. The Z80 signals by the I/O request signal that it wants to exchange data with an I/O device. Read and write decide whether the data should be read or written. At the same time, it outputs the I/O address through the lower 8 bits of the address bus. On my computer, the upper 4 chips select the peripheral device. Bit 4 is assigned to the DART, bit 5 to the PATA device. Bit 0 to 3 address up to 16 registers. With chips like the DART, which were made especially for use with the Z80, this is straightforward. The DART has its own pin for the I/O request, a chip enable which is connected to the inverted bit A4 of the address bus here, a read-write pin and 2 control inputs that decide which interface to use and whether we want to communicate with the outside world or configure the chip. We can connect these directly to A0 and A1 of the address bus. With the TMS 9918 it's not that simple. First, it's a bit confusing that Texas Instruments numbers the data bits in reverse. CD0 is the most significant and CD7 is the least significant bit. So CD0 must be connected to D7, CD1 to D6 of the Z80 and so on. But that's the smallest problem. While the VDP has a read and write throw pin, it does not have the chip enable and I/O request pins required for interfacing with the Z80. This means that we need a bit of glue logic to adapt it to the Z80's control pins. But enough of theory now. I have it all set up and plug the module into the pin header provided. Then I connect my old CRT TV via the later installed video input. Turn it on, et voila, we see the CPM prompt on an old-fashioned CRT. Of course, a bit of Z80 assembly programming was necessary until it finally worked. But we built a real retro computer which can now be used without the help of a PC. For example, I can now write programs in BASIC for it. And how about a game of chess? But when I start a commercial program like WordStar, I only get a mess. But what is the reason for that? Well, terminals are controlled with so-called escape sequences. These define, for example, where the characters should be placed. But the VDP or the driver I wrote doesn't understand them, and so we only see garbage. But apart from that, these programs would also not be useful as they were originally made for the terminals of that time, and these displayed 80 characters per line. But the VDP on the other hand can show only 40 per line in text mode, so we would only see half of it anyway. That's it for now. Consider supporting me on Patreon and get ad-free previews and other benefits. Check it out. Thanks for watching. See you next time.